Your Wi-Fi probably reaches across your home on a good day, but soon it'll be able to reach 10 times further than that and penetrate obstacles that regular Wi-Fi just can't. This is the HaLowLink 2, built around Morse Micro's newest silicon, the MM8108 chip. It runs Wi-Fi HaLow down at 900 megahertz, roughly a third the frequency of normal Wi-Fi, 3 times the wavelength. Same band as projects like LoRa and Meshtastic. That means the signal travels farther and punches through obstacles better than anything most modern routers are capable of. So today, we're testing exactly how far it can go. I'll have one HaLowLink 2 at the base with an uplink internet connection powered by my super sophisticated non-hazardous Starlink rig. Then we'll have a second mobile unit in my car with a magnetic antenna on the back hood. Then we'll just drive away and see how far the link can hold for. But this is just an example to prove a point. House to shed, farm to gate, neighbor to neighbor. If this works, then all those will too. But before Florida Man starts doing Florida things, I want to explain why this actually matters. Most new Wi-Fi generations are chasing headline speeds. Wi-Fi 7, for instance, talks about 40 gigabits per second under perfect conditions, which makes sense if you're beaming sensor data to a robot that needs to react instantaneously. But for most people, those speeds come with a hidden cost: laughably short range. I got on a call with Firas, an RF engineer who stress tests networks for a living.
Like MCS 13 with 4096 QAM, like it kind of works when you are within like maybe 3 to 6 feet from the AP. Once you walk away, like more like it stopped working. MCS 13 is like you need all the stars to be aligned for it to actually work really well.
With those requirements, you're probably better off with a physical connection through either Ethernet or fiber. But if you want a Wi-Fi signal that goes crazy distances at modest to low data rates, the HaLowLink 2 is built for exactly that. It runs OpenWRT, and as the name suggests, it's an open firmware, so no cloud accounts, no apps standing between you and your router. And this entire unit costs $130. It's honestly a great value if you need long haul from 2 points. One unit acts as the base, Starlink in, normal 2.4 gigahertz Wi-Fi for local devices, and the HaLowLink as the long-range bridge. The second unit becomes the remote node. Your phone connects to it over normal Wi-Fi and never knows the packets are traveling over sub-GHz. For my test, I kept the channel width at 8 megahertz, a practical setting that still gives usable throughput. We started with a simple Omni antenna on a tripod at the base and a magnetic mount on the car. But worth noting, channel width is a knob you can turn on this radio. 8 megahertz, 4, 2, 1. Most people see 8 and assume more is better. Wider channel, more throughput. And that is part true. At 8 megahertz, the chip will push around 40 megabits. At 1 megahertz, you're down closer to 4. But there's a quieter trade-off happening on the other side of that knob. Every time you have the channel width, the receiver's noise floor drops by 3 decibels, which translates to roughly 40% more range without changing anything about the transmitter, the antenna, or the chip. That's just physics. A narrower channel is a quieter listening window. Same band, same hardware, same power, narrower channel, signal travels farther. 8 megahertz is the throughput-friendly setting. 1 megahertz is the range setting. For this test, I stayed at 8 because I wanted to see what the useful normal mode could do before I started buying range with bandwidth. At a few hundred feet, the link was strong, around 20 megabits down and 22 up. Already useful for a camera, a sensor, or a remote node. So we kept driving. At 3,500 feet, the link was still alive. Web pages loaded, Reddit worked, upload stayed surprisingly solid even as download dropped to around a megabit. But that's still enough for a gate camera, a trail cam, or a small utility node that just needs to stay connected. Then the mag mount setup started dropping around 0.6 miles. We could have raised the antennas for better Fresnel clearance, but instead we tried something different. Okay, so I'm having trouble getting a connection here. What I'm wondering is what would happen if we put a directional that pointed back that way. And Omni spreads energy in every direction. Since we knew exactly where the base was, we switched to a directional RHCP antenna and pointed it straight back down the road. And just like that, the link came back. So it's pointing right down the street to try to get to that other device. And now the question is, does that show up over here in Wi-Fi Man? Let's see. Yes, it does. Over a mile right now. At 1.05 miles, we were still pulling about 1 megabit down and 10 up. Slow, but real. I could browse the web, check messages, and keep a connection alive. That is layer 2 of the parallel stack in action. Last mile access that actually works when everything else is too far or just too expensive. One quick distinction before we wrap up. People often ask how the HaLowLink 2 compares to the Haven we've shown on the channel all year. They're compatible and they serve different jobs. The HaLowLink 2 is a ready-to-use router. The Haven is a full Raspberry Pi you can SSH into, run Tailscale on, add SDRs or GPS, or turn into whatever custom node you need. HaLowLink 2 connects places. Haven gives you a computer at the place. If you want to understand how all these layers fit together, the routing, the last mile links, the sovereign transports, I built the parallel primer for exactly that. It walks through the hardware, the software, how the radios work together, and how to get your first node running. I even built a solar node from scratch and show how I use AI to move faster on projects like these. The link's in the description below. Because relying on your local ISP is fine for some, but knowing how to run your own private mesh, aim an antenna, and move packets the last mile yourself, that's the part I can help with. And if you like seeing how far we can push real internet over sub-GHz Wi-Fi, you'll probably want to see how far we pushed a reticulum connection. That one might still be my favorite video of the year, so check it out here. Thanks.